Yes, guys. So now I'll give some basic introduction to the AI. Okay. So basically, AI stands for artificial intelligence. So what does AI means? AI means it is a simulation of human intelligence. Okay. So simulation of human intelligence processed by machines, especially the computer systems. Okay. So few examples of artificial intelligence are speech recognition. Okay. So your Amazon Alexa, okay, which recognize the human speech. Okay. No matter in which tone you are speaking, okay, it can easily recognize multiple languages. Okay. So currently here in India, it can recognize English, it can recognize Hindi, and even it can recognize few other languages also. Okay. So day by day its intelligence is increasing. Okay, because earlier it was not used to support Hindi language. Now it can understand the language. See, as we learn new languages, the AI system has the ability to learn the new insights from the information whatever we provide it to that particular system. Okay. So there are many rule associated things like learning, planning, problems, like many things which are associated with the AI system. Okay. Now, in order to build this AI system, okay, so you require two more concepts called as one is machine learning and one more is deep learning. AI is a broad discipline. Okay, so there actually you try to build the human intelligence process by using by so you will put the intelligence into a particular machine. Okay, so it can be a robot, it can be a smaller device, it can be a self-driven car. Okay, so all these are like examples of AI system. Okay, but in order to make them intelligent, artificially intelligent, what we are going to use, we will be using the two major disciplines called as machine learning and the deep learning. These are the two mostly wide areas, okay, which are part of your AI building system. Okay, so AI system. So as seen here, AI is a broad discipline for creating the intelligent machines. Okay, machine learning refers to the system so that can learn from the experience. Okay, so even deep learning is also refers to the system that learn from experience and a larger data set. ML concepts are basically used when you have a smaller amount of data sets. When you have a large data set to be processed, you will use the deep learning. Okay, so using either machine learning and deep learning or using combination of this with some other techniques, we can build the artificially intelligent system. Okay, so as a whole, machine learning represents the many various kinds of systems which can learn from the experiences. Okay, so how they are able to learn it. Okay, so how they are going to get the learning from the experience. Okay, so there are a few different kinds of algorithms which are built based upon this learn like how the particular machine or a system learns. Okay, I'll show you that, but before that I'll tell you like what is the proper definition of a machine learning. Please note down this. So what is machine learning? Okay, so the field of study that gives a computer the ability to learn without being explicitly programmed. Okay, it's a field of study that gives a computer, especially computer can means not like just your laptop or a PC. Okay, so it can be any computing device. Already given example of your Amazon Alexa. Okay, or I can take it as a your self-driving car as a whole. Okay, within that you have a ECU. Okay, so that is electronic controlling unit. Okay, so that is again a computing device which is present inside that. Okay, so study that gives a computer the ability to learn without being explicitly programmed. Okay, so that means say example, there is an example of a Tesla car. Okay, which is actually having a what is the special feature of this particular Tesla cars? Anyone can tell that? Nandan, ಏನಾದ್ರು ಸ್ಪೆಷಲ್ ಫೀಚರ್ ಇದೆ ಏನ್ರಿ ಟೆಸ್ಲಾ ಕಾರ್ದು? ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಅನ್ನೋದು ಒಂದು ಸ್ಪೆಷಲ್ ಫೀಚರ್, ಅದು ಬಿಟ್ರೆ
driving.
It supports automatic driving. Okay, so ಈಗ ನ್ಯೂ ಜನರೇಷನ್ ಒಂದು ಕಾರ್ ಬಂದಿದೆ ಇಂಡಿಯಾದಲ್ಲಿ, ಸೊ ವಿಚ್ ಪ್ರೊವೈಡ್ಸ್ ದ ಸಮ್ ಲೆವೆಲ್ ಆಫ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಬಿಲ್ಟ್ ಇನ್ ಟು ದ ಸಿಸ್ಟಮ್. ವಾಟ್ ಈಸ್ ದಟ್? ಮಹೀಂದ್ರ XUV 700 ಕೇಳಿದ್ದೀರಾ? So they have given some additional features into the car, like automatic driver assistance system. Okay, so if drowsiness detection in the driver, lane alarm, okay, lane change alarm. Okay, so like there's some features they have given it. Okay, so that is in the initial stage of development. Okay, but whereas if you take it Tesla cars, okay, so if you want your car to be parked automatically, so it can do it. Okay, but how it is doing it? Because in every parking slot is not same, right? So there are different parking slots with a different configuration at different places. Okay, so but your Tesla car can do it without any hassle. Okay, so how it is doing? So so here just I'm giving the example. Okay, how this machine learning, okay, it's a field of study that gives the computer the ability to learn without being explicitly programmed. So what does it mean? You need to write a program, but you need not to update the program every time to do a specific task. Okay, so the environment or something around it changes. For example, you build a car parking system for your house. Okay, so what you'll do is you tell that the car that is this is how the parking has to be done. Okay, so this is the distance which has to be maintained, and all these things you will give it. Okay, so that is a one time intelligence you are giving it to your car, and you're writing a program for that. Okay, so car means, so there is a computing device which is inside it. Okay, so it does the parking efficiently. Okay, so but now you're taking your car to your friend house. Okay, so there is a different space available in that for a car parking. Okay, so if you ask your car to do the parking automatically with the settings which you used it for your home, okay, so it doesn't parks it efficiently, so it may end up with doing accidents and all, because you are not putting doesn't have any intelligent systems built into it. Okay, so what is this? It was actually doing just with the help of few amount of data, whatever you fed it, only based upon that it was doing. Okay, so now in order to make it intelligent, that is make it so when you build that particular car with the machine learning concepts, okay, so what we can do is we can put it with the different scenarios. Okay, we can tell that car if this is the scenario, so how we can do it. Okay, parking can be done. Okay, so like that multiple options we can provide it to your multiple sets of data we can give it to your car. Okay, so that is how the car is parked at different locations. So based upon that different location parking videos or parking data, so your car can learn, okay, to the next parking slot how it can do it easily. Okay, if it is able to do that. So example, I given the example of a 10 different areas of parking, how does the parking area looks like, how it has to do the parking and all. So that kind of information I fed it, so about 10 different places. Okay, so now I'm going to the 11th place. If it is able to do that parking automatically there without any hassle, so then we can say that it has learned from that 10 different places experiences. Okay, it was able to do the learning from that 10 different places experiences, and now in the 11th place it is able to do the parking automatically. Okay, if there is an improvement in that 11th place parking, okay, so then we can call that as a machine learning based system. So but if it fails there, we cannot call it, because it is not able to learn anything on its own. Again we need to program it and we need to update it. Okay, so that's one simple example, like how the machine learning, how do you define a machine learning. Okay, it's the field of study that gives your computer the ability to learn without being explicitly programmed. Okay, so this is a simple example which I gave it. So where and all machine learning is used, why we need to learn machine learning? So it helps in automating the automation itself. Okay, so there are many areas where it is doing this. Okay, like in robotics and all, so it plays a major role. Okay, so then getting computers to program themselves, writing software is the bottleneck, like, so it's a very complicated implementation. Okay. So initial stages are high, so when you want to go for the deployment stages, the complexity level increases. Okay, so here instead of writing a program, okay, so what we are doing is, so we are using um, the machine or a system to work based upon the data whatever we feed it. Okay, so this is the traditional approach of programming. Say example, you have a data, then you have program. So depending on your program, so you will get the required output. Okay, so then in machine learning case, the reverse will happen. You have the data and you have the output. So that means for a particular data, what is the output you are going to feed it. So based upon that, computer builds the program. Okay, so then so whatever the new input you are having it, new data you are having it, so for that it predicts the output on its own. Okay, so this is your machine learning. Let me ask you a simple question to better understand this. Okay, so what is traditional approach of programming and a machine learning programming? Hope I already asked this question maybe, but I'm still repeating it. This is a simple question I'm going to ask you people. You have an input variable. So this is I'm calling it as a data. So I have a program. So the program is equal to, in program I am writing output is equal to 3 plus data. This is traditional approach. There is one more data equal to 1, 2, 3, 4, 5. Output is equal to 4, 5, 6, 7 and 8. Priyadarshini,
yes sir.
so you are aware of this question?
No sir.
Tell me, and like I have, see, this is traditional approach. Okay, say example you want, so I have given this inputs. Okay, so based upon that, what is the output?
3 plus data.
So this is the program I need to write it. So then you want for any kind of input. Say example, if my data is 7, so then what is your output?
10.
No, if
10.
10, right? So if your data is 15,
18.
18. So that is a simple
18.
program we have written it, right? So, but this is actually what we do it in the machine learning. So in a traditional approach of programming. So we will be having my input and corresponding output I'll give. So output will be calculated based upon the program whatever I'm going to write it here. This is the program I written. Okay. But in ML we'll do reverse. So what we'll do is we'll give the data. Instead of writing a program, I'll take an output variable and I'll pass on the outputs, corresponding outputs. So this is corresponding output, right? For 1 you have 4 output, for 5 8 output. So this simple data I'll feed it. Okay, so next if I ask the computer, so what is the, if my data is 10, what is the expected output? Sanjay?
13.
It is 13, right? If your system is able to give you the exact result as 13 or 12.9 or 13.1, okay, so will you be happy or not? So will you consider that result or not? Yes, Priya.
Consider sir.
You will consider because it's a very closest result, so that your computer has given you, right? So but for this I don't write a repeated program again and again. Okay, So this is what actually happens in the machine learning case. Okay, you feed this input and output, so it should be able to predict the result based upon your the input and output relationship. What is the input and output relationship? What is the input and output relationship in this particular example, Sanjay? Sanjay Hoskar. So what is the input and output relationship here? Your output is equal to
3 plus data.
3 plus data. That is the relationship, right? Okay. So that means by looking at this data, your computer should be able to guess this. If it is doing this to the closest value, okay, so then that means that machine has learned something from this data whatever you given. Otherwise, for input 10, if it is giving you the output as 10 or 16, will you be okay with that? No, right? You don't accept that kind of result. Yes? So that residual error, what is the actual value is 13. So you are getting 12.9. Okay, 12.9. So that is closest value. So that means the error between the original value and the predicted value is less. So you can accept that kind of you can accept that result. Okay. So this is possible with the help of your machine learning. I don't need to feed this output is equal to 3 plus data relationship. Your machine can automatically recognize this. Okay. If a system able to look into data and make inferences based on the data provided, we can say machine learned. You can say machine has learned. Okay. Now I'll have you few more question. One more question I'll be asking you. Okay. Now Mahantesh.
Sir.
How are you, Mahantesh?
Sir.
Mahantesh, how are you?
Fine. Sir.
Fine. Okay. So where are you from, Mahantesh?
Sir, Ballari hತ್ರ ಒಂದು ವಿಲೇಜ್.
ಬಳ್ಳಾರಿ ಹತ್ರ ವಿಲೇಜ್. ಓಕೆ. ಏನು ಮಾಡ್ತೀರಾ ನೀವು ಮನೇಲಿ? ಏನಿಲ್ಲ. ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡೋಲ್ಲ ಮತ್ತೆ ಕ್ಲಾಸ್ದು? ಏನಿಲ್ಲ ಅಂತೀರಾ? ಏನ್ರಿ?
ಮಾಡ್ತೀವಿ.
ಹೇಳಿ. ಮಹಂತೇಶ್, ಇದು ನೋಡಿದ್ದೀರಾ ಡೇಟಾನ? If I feed this new data set, this is a new data set. Okay. So what is the expected output for input is equal to 5 and input is equal to 15 and input is equal to minus 5. Okay, so we'll ask one by one. So let's answer, we'll ask the answer for Mahantesh. So the answer for input is equal to 5. What is the output?
9.
ಏನು ಹೇಳಿ? 9. Okay. Next, Neetu DG, what is the expected output for this particular input is equal to 15? Mm-hmm.
27.
27. Okay. Lakshmi Putra Reddy. What about -5? Meghana KU. Meghana KU. Yes.
Yes, sir.
Meghana, what is the answer for -5? Okay, so Lakshmi, yeah, Lakshmi has given the answer. Okay, now we'll start. Okay, Lakshmi. So why is the answer is -11? You can write it in the chat window, no issues. Others, who are given the answer. So that is Mahantesh, and who is one more? Give the answer as 27. Neetu, right? Yeah, Neetu. You also give me the reason for why that answers are correct. The answers are correct. So please give the reason. The answer is this answer is not correct actually. This answer is 29. Is there any relationship between input and output? Rachana?
Sir,
Is there any relationship between input and output? Here we
incrementing by 1, 2, 3.
no, I have given here. So what is incrementing by 1, 2, 3?
Yeah, like 1 means it's 0 means it's 1 means
That's how you are thinking. Very good, Rachana. But that way you cannot give me the answer for 500, right? If I ask you to give me the answer for 500, how do you calculate it? So what about 500? How do you give it? Okay, the relationship is very simple. Okay, so that's correct, Meghana. Okay, the answer you are giving is correct. Okay, so what is the input there? -5. So let's look at this relationship. The output is equal to, you guys are predicting with the like looking at the data, not with any relationship, right? Exact direct relationship. Yes, Rachana?
Yes, sir. I think
You are
I'm mistaken.
no, you are not mistaken. So this is even Lakshmi. That's how you also did, right? So inference by
Yes,
looking
sir.
at the data. So most of you did the same thing. Okay. So the actual relationship is this one: 2 times the your input.
Input is 1 increase, sir. Output is 2 increase.
No, not required. Okay. So it's very simple. 2 times the input minus 1. That's a simple relationship. Now you can calculate it and you can give me any input, you will get the output. That should be exactly correct. So tell me, we'll start with 0. Okay. So what is the output for 0? 2 into -1. Alas, 2 into 0 is 0. You will be getting -1. That's correct, right? Okay, we can verify it for 4. 4 into 2 is what? 8. 8 minus 1 is 7. So according to that 15, when the 15 is the input, 15 into 22, 30 minus 1. So you will get output as 29. Minus 5 into 2, minus 10. Then minus 10 minus 1 is minus 11. Yes, guys? Is the relationship correct?
Yes, sir.
Yes. See, like you people did some inference by looking at the data. So that's how your mind thinks, right? It doesn't wait for you to give the relationship. Now if I change the data once again, so what you have to do it again, I have to find out some other relationship here. So that becomes difficult in every possible scenario. If you start looking for the relationship, so it becomes difficult in the real case world. Okay, so when I give a large quantity of the data, if you try to find the relationship using this kind of anything straightforward function, it becomes difficult. In that case, your machine learning comes into picture, where it can look into the data, that is input and output. It can build similar kind of relationship. Okay, so like how I built here, so I built one more here. Okay, so both are purely based upon the input and output variables. Okay, so that is input and this is my output. Okay, so when I do this, when we provide both input as well the output, this kind of ML is called supervised ML. Okay, Preetham, so what is this? Read it.
When we provide both input as well the output, this kind of ML is called supervised ML.
This kind of machine learning is called as supervised machine learning. That means it is like I am teaching you how do you write ABCD. Okay, okay, I am actually writing you how does an A looks like and how does an B looks like, and I am telling you what is A and what is B. That is the difference between them. Like is I am giving the label to the A as A. So this is specific style of the character, right? So let me give you still more better. Okay, 1 minute. So what is this guys called as? This is A. But when you are kid, if I teach this as B, will you learn it as B or A?
No, sir.
No, you will be learning it as B only, right?
For first time we will learn it.
Yeah, first time you will be learning. So that is why if I am teaching in that way, so your understanding is what? It is B, right? So that is the label. What is the label I given to this shape? What is the label I given to this shape? I call this as A. So for this shape, I am giving the label as B. Okay. So then what is this? This is circle. So this is, you call it as a square. You call this shape as a rectangle. Okay. So all this because I have given the label. But if I give this shape, okay, and if I telling this as square, will you accept it?
Yes, sir.
Will you accept it as a square? So if I am teaching you in that way, okay, so that's not. So it is a labeled data. Okay, this is the input I am giving it to your machine learning algorithm. So example, I given it a square box, images of the squares I given it, and the rectangles I given it. Okay, so while giving, I had to tell what is that image is, if it is whether it is a square or a rectangle. So if I give this information, it is called as supervised machine learning. Okay, that means I'm giving the label. Okay, so then without labels, if you try to feed it, so how it understand which one is square and which one is a rectangle? Is there any chance? No, right? So there are other methods out there, I'll talk about later, but as of now, supervised learning means, okay, this. Okay, so this is an input which I want to feed it. So if I'm asking you the question, what is this? And if I'm asking you, what is this, Preetham?
Ellipse.
Ellipse. So that is your output.
Yes, sir.
Yeah, so this is the input for you, and for that you give on the output. So you already been trained to recognize this shape, right?
Yes, sir.
So but that means you already have the, when you are learning, so okay, your teacher has taught you, so what is this shape is, right? So they shown you this shape and they given the name for that shape. Yes, So that is actually called as supervised learning. Okay, and also you have somebody to monitor it. If you are doing a mistake, so so in supervised learning we can easily understand, okay, so whether you are doing it correctly or not, whether you are doing it correctly. So who will do it here in this particular case? When you started learning, your teacher, geometry teacher, was doing that task, right? Pritam,
Yes, sir.
your geometry teacher was doing the task, okay, of what? Monitoring your performance, okay. So when he or she was doing it, okay, so what was this, like you will be given a shape and you are supposed to write the, so which shape it is. So they may be given example of 1-2 shapes as a reference, and your answer should be ellipse, and one more answer should be rectangle. If you are doing a mistake for ellipse, if you are telling it as a square, sorry, for ellipse if you are telling it is circle, so then you are actually doing a mistake, okay. So like that, for 100 different shapes shown, or sorry, for 10 different shapes shown, if you are recognizing 9 correctly, one mistake if you are doing it, so what is the percentage of accuracy you are doing it?
90%.
It is 90%. So that is a performance we can measure it in the supervised learning, okay. And if there is an error, so your teacher is there to rectify it and tell you. So then what you will do, you will update that thing in your mind, okay. So next time they show you, so will you improve it or not?
Yes, sir. We'll correct it.
Yeah, so this is actually what happens in the supervised learning, okay. So you will be given a data input as well as the output. That means, so see, in other words, it can be called as labeled input will be provided in the supervised machine learning, okay. Clear? Okay, so this is also used in many areas, okay. So we now learned what is machine learning. So now we saw what is supervised learning, okay. So what is traditional approach of programming and what is machine learning based approach of programming, okay. In traditional approach of programming, we provide data along with the programs, so that program will give you the desired output, okay. In ML, we provide the data along with the output, okay. So then computer will make some predictions, okay. So it builds a program, okay. That program can be used in the future to give the result for the new set of data, okay. Tom Mitchell, another Tom Mitchell's theoretical explanation about machine learning. A computer program, please note down this, all of you. Okay. So there is a variation in the experience in learning this given character as A or not, okay. So when you do that, okay, so if its performance is increasing, that means in recognizing this new character, okay, if it is able to do with the higher degree of accuracy, okay, so then you can call that as a machine learning model, okay. That means machine has learned, okay. So that means if a machine improves its performance, okay, so in doing a particular task, okay, based upon the experiences, okay, so then you call that kind of system as a machine learning system, okay. A computer program is set to learn from experience E with respect to some class of task T. That means, so you have written a program to a machine, like you have written a code for a particular, in order to do a particular task, okay. So I'm using a performance measure there, okay. If that performance measure is increasing in doing that particular task, okay, so based upon the experiences, okay, based upon the experiences, so you can call that as a machine learning model, okay. So this is what the a full-fledged definition given by Tom Mitchell, okay. And mostly you all will refer this textbook by Tom Mitchell, and this is the first definition you would find it there, okay. In simple words, this is the simple explanation of what is machine learning. Okay, so let's start with Mahantesh.
Sir,
So tell me, Mahantesh, what is machine learning?
computer program is said to be learned from experience E with respect to the same classes of task P and performance measure P. If its performance at task in the T as measured by the P improve with experience E. Sir.
ಅಲ್ಲ ರೀ ನಾ ಇದು ಓದ್ರಿ ಅಂತ ಹೇಳಿಲ್ಲ. ಸೊ ಇದು ಬಿಟ್ಟು ನೀವೇನಾದರೂ ಹೇಳ್ತೀರಾ ಸಿಂಪಲ್ ವರ್ಡ್ಸಲ್ಲಿ ಇದನ್ನೇ ಇದು ಏನು ಅರ್ಥ ಮಾಡ್ತಾ ಹೇಳಿ ನಿಮಗೆ ಮಹಾಂತೇಶ್, ವಾಟ್ ಇಟ್ ಈಸ್ ಟೆಲ್ಲಿಂಗ್
Sir,
ಹೇಳಿ.
T performance P sir ಅದು measure by improve the performance ಅಲ್ಲಿ measure P.
ಈಗ ನೀವು ಒಂದು ಟಾಸ್ಕ್ ಬರೀತೀರಾ ಅಂದರೆ ನಿಮ್ಗೆ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ ಕೇಳ್ರಿ. ಓಕೆ, ಸಿಂಪಲ್ ಅರ್ಥ ಮಾಡ್ಬೇಕಂದ್ರೆ, ಸೊ ಈಗ ನೀವು ನಿಮಗೆ ಕ್ಲಾಸಲ್ಲಿ ಲೆಕ್ಚರರ್ ಟೀಚ್ ಮಾಡ್ತಾರೆ, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಎಲ್ಲ ಟೀಚ್ ಮಾಡ್ತಾರಲ್ವಾ, M1 M2 M3 M4 ಡಿಪ್ಲೊಮಾ ಬೇಸಿಸ್ ಆರ್ PU ಬೇಸ್ಡ್?
ಡಿಪ್ಲೊಮಾ
ಡಿಪ್ಲೊಮಾ. M3 M4 ಅಟೆಂಡ್ ಆಗಿದ್ದೀರಲ್ವಾ?
ಸರ್.
ಎಕ್ಸಾಂಪಲ್ M3ಅಲ್ಲಿ ನೀವು ಕ್ಲಾಸಲ್ಲಿ ಎಲ್ಲ ಪ್ರಾಬ್ಲಮ್ಸು ಸಾಲ್ವ್ ಮಾಡಿಸಿರ್ತಾರ?
ಇಲ್ಲ ಸರ್.
ಎಕ್ಸಾಮಿಗೆ ಬರೋದು
ಇಲ್ಲ.
ಮಾಡಿರಲ್ಲ. ಬಟ್ ಇಂಟರ್ನಲ್ಲೂ ಆದರೂ ಅಷ್ಟೇ ಅಲ್ವಾ? ಬಟ್ ಮೋಸ್ಟ್ಲಿ ಇಂಟರ್ನಲ್ಲಲ್ಲಿ ನೀವು ಸ್ಕೋರ್ ಮಾಡ್ತೀರಾ, ಯಾಕಂದರೆ ಅದೇ ಕ್ವಶನ್ಸು ಸಿಮಿಲರ್ ಕ್ವಶನ್ಸೇ ಕೊಟ್ಟಿರ್ತಾರೆ ಅಲ್ವಾ? ಮೋಸ್ಟ್ ಆಫ್ ದ ಕೇಸಸ್. ಎಕ್ಸಾಂಪಲ್ ಏನಂದರೆ ನಿಮಗೆ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟಾಪಿಕ್ಕಿಂದ ಒಂದು ಕ್ವಶನ್ಸು ಸಾಲ್ವ್ ಮಾಡಿರ್ತಾರೆ. ದಟ್ ಈಸ್ ದ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ದೇ ಆರ್ ಗಿವಿಂಗ್ ಯು. ಓಕೆ, ಹೌ ಟು ಸಾಲ್ವ್ ಎ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್ ಅನ್ನೋದಕ್ಕೆ ಒಂದು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಕೊಡ್ತಾರೆ. ಮೇಟ್ರಿಕ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡೋದು ಯಾವ ಥರ ಅಂತಂದು ಹೇಳ್ಕೊಟ್ಟಿರ್ತಾರೆ ಅಲ್ವಾ? ಸೊ ದಟ್ ಈಸ್ ದ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಯು ಗಾಟ್ ಇಟ್. ವಾಟ್ ಈಸ್ ಯುವರ್ ಟಾಸ್ಕ್? ಯುವರ್ ಟಾಸ್ಕ್ ಇಸ್ ಟು solve the matrix problem. Okay, your task is to solve that problem. Consider, then they will conduct a test for you, okay, to check how you learned based upon that experience they provided. Okay, so if you are scoring better in that, so that means you learned that you already know how to do the particular, that is task, that is solving the matrix problem. Yes, if same questions is coming, okay, you will definitely score more. Okay, if you are getting the similar questions which are already done in the classroom, you will definitely score. If there is a minor twist in the question, if you are able to do that, okay, and if you are able to score better, so that means you are able to completely understand how to solve that, right? So that is called as machine learning. Okay, so that means that is the intelligence based upon by looking at around all the experiences it got, like various kinds of examples which your lecturers thought. So those are called as experiences. Okay, so using that, if you are able to solve a new problem, okay, so that means you have learned. Okay, similar approach is here also. Okay, a computer program is said to learn from experiences with respect to some class of task T. Okay, ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಮೆಷರ್ P. ಓಕೆ, ಅದು ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಮೆಷರ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ಆವಾಗ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಮೆಷರ್ ಮಾಡಿದಾಗ ಆ ಟಾಸ್ಕ್ನ ಕಂಪ್ಲೀಟ್ ಮಾಡೋಕ್ಕೆ ಇಫ್ ದ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಮೆಷರ್ ಈಸ್ ಇಂಪ್ರೂವಿಂಗ್, ಓಕೆ, ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಮೆಷರ್ ಏನೋ ಇಂಪ್ರೂವ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ತೋರಿಸಿದ್ರೆ, ಸೊ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ದ್ಯಾಟ್ ಆಸ್ ಎ ಲರ್ನ್ಡ್. ಓಕೆ, ದಟ್ ಸಿಸ್ಟಮ್ ಹ್ಯಾಸ್ ಲರ್ನ್ಡ್ ಸಮಥಿಂಗ್. ಅದರ್ವೈಸ್ ವಿ ಕ್ಯಾನ್ ನಾಟ್ ಸೇ ಇಟ್ ಎಸ್ ಎ ಮಷಿನ್ ಲರ್ನಿಂಗ್ ಬೇಸ್ಡ್ ಸಿಸ್ಟಮ್. ಓಕೆ, ಎಸ್, ಓಕೆ ಮಹಂತೇಶ್. Rachna?
Yes, sir.
Can you repeat in simple, like what do you mean?
Yes, I have to read that.
No need to read it. Okay, whatever
I
the understanding you got it as what is machine learning basically?
Computer improve their skills automatically through experience.
Automatically, no, it's so computer has to improve its performance. Where it has to improve its performance? In doing a particular task. Okay, so task is what? Say example, you take selfies.
Yes, sir.
ತಗೊಳ್ತೀರಲ್ವಾ? ಕರೆಕ್ಟಾಗಿ ಹೇಳಿ, ತಗೊಳ್ತೀರಾ ಇಲ್ವಾ?
Yes, sir.
ಓಕೆ, ಬ್ಯೂಟಿಫೈ ಯೂಸ್ ಮಾಡ್ತೀರಾ ಇಲ್ಲ? ಬ್ಯೂಟಿ ಆ್ಯಪ್ ಯೂಸ್ ಮಾಡ್ತೀರಾ ಇಲ್ಲ ಅದರಲ್ಲಿ? ಇವಾಗೆಲ್ಲ ಮೊಬೈಲ್ಸಲ್ಲಿ ಬಿಲ್ಟ್ ಇನ್ ಇರುತ್ತೆ ಅಲ್ವಾ? See, so its task is to what? Improve the facial parts of the face, okay? So give the good quality of the picture, right? So its task is to what? That app task is to what? Improve the quality. It's actually AI based one, right? So it doesn't give the same effect to everyone. Does it give? So will it give the same effect to everybody? No, it doesn't give the same effect to the everybody. It gives a different effects to the different people. So that is so when the app is built, different faces has given as an input. So when it has learned through different experiences, okay. So that is beautifying the like expression of the face or the other features of the face, okay. So it is if it is doing that with the performance improvement, okay, so then you can call that as a machine learning model, okay. So yes guys, so always there is a performance measure in doing a particular task, okay. So in order to do that task, it requires some kind of experiences, okay. So that performance measure is improving on a new data, okay, then you can call that as a machine learning model, okay. So please remember this like definition writing is very simple, but you need to be more elaborative, like how this is actually, what it actually means, okay. That's why I'm just putting 15 to 20 minutes of stress only on this particular definition, okay. Meghana?
Yes, sir.
Meghana, what is the supervised machine learning means what? Raghavendra.
Yes, sir.
ನೀವು ಚೆಸ್ನ ವೈ ಯು ಆರ್ ಥಿಂಕಿಂಗ್ ಇಟ್ ಇಸ್ ಅ ಸೂಪರ್ವೈಸ್ ಲರ್ನಿಂಗ್ ಅಂತ ಯಾಕೆ ಅನ್ಕೊಂತೀರಾ?
ಅದು ಡಿಫ್ರೆಂಟ್ ಪೀಪಲ್ ಜೊತೆಗೆ ಡಿಫ್ರೆಂಟ್ ಆಗಿ ಆಡುತ್ತಲ್ಲ ಅದಕ್ಕೆ.
ಇಲ್ಲ, ಈ ಎಕ್ಸಾಂಪಲ್ ಚೆಸ್ಸಲ್ಲಿ ಎಷ್ಟು ವೇರಿಯೇಷನ್ಸ್ ಇರ್ಬೋದು ನಿಮಗೆ? ಅಲ್ಲಿ ಡಿಸಿಷನ್ ಯಾವ ಥರ ಆಗ್ಬೇಕು ಹೇಳಿ? ಈಗ ಸೂಪರ್ವೈಸ್ ಲರ್ನಿಂಗಲ್ಲಿ ಅಂದರೆ ಇಟ್ ಈಸ್ ಲೈಕ್ ಯು ಆರ್ ಗಿವಿಂಗ್ ಸಮ್ ಅಮೌಂಟ್ ಆಫ್ ಡೇಟಾ. ಆ್ಯಕ್ಚುಲಿ ಇನ್ ಸೂಪರ್ವೈಸ್ ಲರ್ನಿಂಗಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಸಮ್ ಇನ್ಪುಟ್ ಔಟ್ಪುಟ್ ಎರಡೂ ಕೊಟ್ಟಿರ್ತೀರ ಅನ್ನೋದು ಒಂದು ಕಾನ್ಸೆಪ್ಟ್. ಅದ್ರ ಜೊತೆಗೆ how it has to act in the real world, okay. So if it is working only with that simple knowledge, okay, so that is called as supervised learning. But in the case of your chess playing, okay, so you cannot give all possible scenarios and feed it to the machine, okay. So Vishwanath Anand, how does Vishwanath Anand thinks, okay, so based upon that your machine has to understand his move and then it has to play. So that is an actual example of a supervised, not supervised learning. It is an example of a reinforcement learning, something called as. So that means it has to take the decision of the moment itself. Though we give the some sorts of inputs and outputs, but it is called as a reinforcement learning. The reason why we call it as a reinforcement learning is it works on the basis of the moment, okay. But in the case of your fruit recognition example, okay, is there any changes can happen? So you may be having hundreds of fruits, okay, apart from anything else you can get it. You may get a broken apple or you may get a different colors of apple. So if you give all those possibilities, okay, so you have only limited possibilities in the apple variants, right? Oranges, lemons, okay, so only you have got a few variations in that, okay. So the amount of data you feed it in supervised learning is limited, okay. Whereas in reinforcement learning is used when you want to make the decisions based upon the current scenarios, okay. So those are called as puristic AI systems, okay. So they usually use something called as RL systems, okay. And there is some multiple combinations of supervised learning also used in that chess playing, okay. It's actually a very big system. Good example chosen, but not an example of particularly supervised learning alone. It's an example of a whole AI system. Raghavendra, got it? Okay.
Yes, sir.
Fine, guys. Okay. So now you got some fair idea about what is supervised learning. Okay. In supervised learning, there are variants are there. Okay. So one is a concept of regression and one more is a concept of classification. classification. Okay. What do you mean by regression? Regression is all about predicting the continuous valued outcome. Predicting the continuous valued outcome. Example: rainfall prediction. Okay. Example is rainfall prediction. Okay. Another example. Okay. Predicting age of a person looking at image. This is another example. Stock price prediction. Okay. Now I'll ask Navya B. Navya Bandari.
Yes, sir.
Navya, look here. You are given an example of a predicting the age of a person looking at the image. Okay. Looking at the image, you need to predict your age. Okay, that is an example of regression. Why I am calling it as an example of regression? So what is your age, Navya? Navya.
By experience, sir.
No, I'm just asking you. What is your age? Simply, can you tell? 21?
21.
21. To be exact, what is your age? 21 years or 20 years, 6 months or 8 months or 21 years, 9 months? Something
21
like
years.
21 years?
20 years. 20 years and
20 years?
10 months.
10 months. Okay. See, your machine learning model can predict your age as 20 years and 1 month. Okay. It can predict it as 20 years and 8 months. It can predict it as 20.9 also, because your age is a continuous value. Okay. So now you are predicting this value next year. So if it has to look at your image, okay, new image, it has to give you the new value. Okay. So but now your value will be close to your actual value. Okay. But it is a continuous value. It is not fixed. Is that fixed? No. Okay. So now next. Okay. So this is an example of your particular regression. Okay. So all we'll be doing is predicting the continuous valued outcome in the case of regression analysis. Okay. So stock price prediction. It's an example. Now current, so people not be aware of, many of you not be aware of stock prices, but few you might be having some knowledge on, or maybe good knowledge on stock price. Okay. So who is having a knowledge on stock price here? Stock market. Yes, Lakshmi. Okay. So tell me, so which one you are looking at, Lakshmi? Like currently today's, like, have you checked any stock price of any particular shares, particular company? You can put it in the chat window. See, if you look at Tata Motors, Bajaj Finance, okay, Tata Motors. What is the value at today's price for Adani Power? Please post it. Like you have some disturbance from your end. Adani Power, what is the stock price? So we'll look at this. It is 91 rupees. Will it be exactly 91 rupees? Okay. So that is today's current price is 91 rupees based upon the previous performance. Okay. So we can predict what is the Adani Power's price is going to be. Okay. So tomorrow it can be 91.1, or it can be 93 rupees, or it can be 94.2, 94.3. So these are like continuous valued outcomes which so that means there is no set outcomes. There is no set outcomes which we can expect it. Okay, so that is what happens in the case of your regression analysis. Okay, rainfall, it can be 100 millimeter, it can be 99 millimeter, it can be 99.4 mm. Okay, continuous valued outcome. Okay, so that is in the case of regression analysis. So classification, so it is about predicting the discrete set of outcomes. So here we focus on predicting the discrete set of outcomes. Okay, example, so given the predicting quality of water as good, bad, suitable, then washable. Okay, there are three variants, okay, which we can predict based upon the pH value. So based upon the pH value, based upon the color, based upon the turbidity. Okay, so based upon its temperature. Okay, so we can decide whether that water is good, bad, or it is okay for washing application. Okay, so based upon these values I need to predict this outcome, whether the water is good or bad or washable. Okay, so apart from this, when I train this machine learning model, okay, so I'll give some values to this and I'll give the label as water is good or bad. So even based upon pH level or color or turbidity and temperature values. Okay, so when I train this model, okay, so what are my expected outcomes, Rachana? What are the expected outcomes?
So,
What are the expected outcome here?
good, I think 7 around.
No, leave with that value. Okay, so what are the expected outcomes are good,
Good, bad, washable.
washable. So can I, once I train this model, can I expect anything apart from this? No, right? So it
Yes.
can be, the outcome can be any of the three, right?
Yes,
So
sir.
that means outcome is fixed. That means you have a discrete set of outcomes. Okay, so this is about your classification. Now I'll give you one more example. Okay, so given image of a person, classifying gender. Okay, Rachana, what are the possible genders we can classify? Say example, if I have given one person image. Okay, so what are the possible scenarios available? Sanjay?
Sir?
So what are the possible options available? So when I give a person's image, okay, so what are the classification available?
Male, female, transgender,
Yeah, male,
third gender. Like
female, transgender. Okay, three classes we can do it. Anything apart from this you can do it? No, right? So that means these are outcomes are fixed here. Okay, the expected outcomes are fixed. Okay, so if you train your machine learning model only for male and female, so you don't have any option. Either you need to predict it as a male or it is a female. Only two outcomes. If you train your machine learning model, okay, to predict the given input image as either cat or a dog, your expected outcomes are what? Either cat or a dog. Even if you feed a lion's image, your outcome is going to be either cat or a dog only. Okay. So because that model has only ability to predict it as either cat or dog. Okay, so it cannot give anything in between status. Okay, so in classification your role is to predict the discrete set of outcome. Okay, in the case of regression your role is to predict the continuous valued outcome. Okay, so all of you taken a note of these things? Yes, taken? Yes, fine, good, Priya. Fine. Okay. Yes, we have done some basic introduction. So in the case of supervised learning, you can find regression and classification. In regression, there are many kinds of regression. Okay, so in case you want, you can note down this definition. Those who not noted down. In supervised learning, we are given a data set and already know what our correct output should look like. Okay, and having the idea that there is a relationship between the input and the output. Okay, so this is what the definition of your supervised learning. That means we already know what is the expected outcome. Okay, so based upon that, we are going to train the model. So here you have a regression and classification. In regression, you have a linear regression, multivariable regression, polynomial and logistic regression. Okay, neural network regression, support vector regression, like that. Various kinds of regression are available within the regression itself. Okay. Again, in classification, you have KNN classification, SVM, CNN, ANN classifications. Okay, there are many are there. So which will be given along with your regular class. Okay. So we'll be having a separate class on regression class and some classification. Okay guys, noted. Okay. So in the unsupervised learning, okay, so unsupervised learning allows us to approach the problem with a little or no idea what our results should look like. So we can derive structure from the data where we don't necessarily know the effect of the variables. Okay, so without knowing the what happens with the outcome we are going to get. Okay, so we need to make some kind of inferences from the given input. Okay, so we need to get some results, so with the given input. Okay, so it's basically in unsupervised learning, what we try to do is we'll try to get some kind of structures. Okay, by clustering the data based upon the relationship within the data, given data. Okay, so that is what your unsupervised learning. Okay, so I'll give you the complete proper definition of it. Okay, now, so what is the population of India?
$135 crores.
135 crores. Okay. We have poor, rich people, okay, middle class, upper middle class. Okay. So how do you do this classification, guys? How do you tell who is poor? How do you tell who is middle class? And how do you tell upper middle class? How do you tell rich? How do you tell billionaires? Okay, how do you tell? So all this
Annual income.
annual income based, completely annual income based. So there are 130 crores of people, sir. Then how do you do that? So can you check each and everyone's income and start doing this when you have larger data? Instead, what we can do is, okay, in simple words, when you have this large quantity of the data available, okay, so take the data. Okay, so I want to make a 3 different categories of the so income based 3 clusters. I want to build it. Okay, so then I can label that as a rich and all. So instead of having that rich, middle and upper class, what we will do is, okay, so now a banking system want to promote its new product, or there is a new company which want to promote its customers, so promote the some new product to the customers who have a higher income. Okay, so they can be upper middle class, they can be middle class people, they can be rich also. Okay, so in the rich category or middle class, what happens is, okay, if you giving with a specific condition, like poor means 0 to 50,000 income. Okay, so middle class means 51,000 to 3 lakhs income, that is 300,000. Okay, so upper middle class means something like that, they have got 300,000 to thousands, okay, maybe like something like that. Okay, so 3 lakh to 1 crore. Okay, so rich people, then how do you set all these things? Okay, so greater than 1 crore, can you set like that like that? Okay, no, it becomes very difficult because there is so huge data is there. Okay, what we can do is, okay, if I want to cluster this data, okay, so then if you start putting up these conditions and all, it becomes very difficult. It becomes very difficult to classify the data. Okay, so then in case what we'll do is, so you given the data, okay, you don't label the data as a poor, middle, or upper, or rich. Okay, instead you want the data to be clustered. Okay, you want the data to be clustered into 3 different groups. Okay, some people who are coming around the similar kind of income, so maybe like I'll give you some values here. Okay, so let us look at this example. Let me open the notebook. Wait a minute, guys. I'm going to import numpy as np. Okay, now a is equal to np dot random dot rand int of 1 to 500 comma 100 samples. So these are the values. Okay, now consider these are the incomes. Okay, in terms of thousands. Okay, so you have the values between, then how do you cluster how do you separate them? You cannot put the conditions and do it, right? Each and every conditions if you start putting it. So just in this case, what I'll do is I will just give a minute, guys. By clustering the data based upon the relationship among the variables in the data. Okay, so it can be similarity is the one criteria, there can be some other criteria as well. Okay, so whatever the relationship they have, it based upon that, if we are able to derive some structure and able to do the clusters, okay, so then you can call that as a unsupervised learning. Okay, but we are not sure exactly the outcome which we are going to get actually serves our purpose or not. Okay, but some cases we are actually expecting some inferences may be there, sometimes you may not be having it. Okay, when you have some inferences, it can be called as semi unsupervised learning. Okay, so otherwise it can be called as simply unsupervised learning. Okay, so you can take many examples. Okay, take a collection of hundreds of essay written on the economy or any other topic. Okay, find a way to automatically group these essays into smaller numbers that are somehow similar, related by different variables such as word frequency, sentence length, okay, page count, and so on. Okay, so example, I want to cluster the data so which are having a similarity based upon the number of pages. Okay, so it can the algorithm can do it on its own. Okay, so that's a somewhat kind of algorithm. Okay, so it is called as unsupervised learning. Okay, so expected outcomes may be known or may not be known in these cases. Okay, but we don't give any labels to the outcome. Okay, so here it is purely job of the will be working purely by looking at the input data in the case of unsupervised learning. Okay. Yes, guys, so this is both your supervised and a unsupervised learning approach. Okay, so we'll be learning in unsupervised learning. There are many variations are there. Clustering is one of the approach. So then there is one more approach called as dimensionality reduction. Okay, based approaches. Okay, so we can also learn that. Okay, we'll be doing some exercises based upon this both supervised and unsupervised learning techniques.